Okay, so we're going to spend a couple of days talking about graphs before we start graphing. Okay, the nice thing about today is we're going to work with graphs and in terms of radians, which can be a little bit tricky, and we're going to kind of review the properties, and you're going to get to start thinking about graphs of sine and cosine before you have to actually graph them. Because graphing them, it's not too bad, but can be a little bit tricky for some people. So let's go over. So first of all, we're just going to review. We've talked about this a little bit when we reviewed grade 11, but we're going to review just the definitions that are involved in periodic functions in general, but in sine and cosine, and then we're going to start looking at them like on the graph and talking about a few other things. Okay, the period. Again, I'm not going to go through these like really in depth. They're there if you want to read over them and think about them. Period is a horizontal length of one cycle. We calculate the period. We talk about the period. That's a pretty big deal, being able to find the period. Okay, so it's one cycle. The amplitude is half the distance between the max and the min. That's an easy way to find it. If you have the zero line, if you know where the middle is, then it's the distance from the middle to the max or the middle to the minimum. That's the same as saying halfway between the max and the min, right? The phase shift is the amount by which it's shifted horizontally. It's like the horizontal shift or the horizontal translation, but in a periodic function, we call it a phase shift because sine, like, it's everywhere horizontally already. So shifting it is kind of like a weird idea. But you think about it in terms of with respect to the basic function or the base function, the parent function. So you think about it in terms of that. Where does our first cycle of sine start in our parent function? What's that shift relative to that, right? Vertical translation is straightforward, the amount by which the graph is shifted or translated vertically. Okay, again, with respect to the parent function. This is really important. Each trig graph we look at for 5 important points. Those 5 points will define one cycle of our graph. It's really important. Okay, and those must be located when we start graphing. It's not really important for today, but on lattice points. What's a lattice point?
It's like on the graph, right? Where there's like where two lines meet.
Yeah, where two like grid that you're given or that you make where those meet. Okay, those are lattice points where the grid lines meet. So in other words, if you calculate your scale wrong, one or more of your points will be between grid lines. Not okay. That means you've calculated your scale incorrectly. Okay, and that's going to be the challenge in a couple of days of graphing. One of the big challenges. So you want to know where these 5 points are for, and you probably do. We already talked about it a little bit for sine and cosine. You want to know where they are ahead of time. And then all of the work we do when we're graphing, or even when we're, the stuff we do today, is thinking about how those 5 points changed. Okay, and that's going to do all the work for us. One other thing that we're going to talk about, this is new to in grade 12 that you haven't talked about. So if you haven't written anything down, you might want to start writing this down. Intervals of increase and decrease. It seems like it should be pretty straightforward, but it's actually something that a lot of people struggle with. Whether a function is increasing or decreasing at any given point. And what are the intervals of increase and decrease? We're also going to learn a new notation that you probably haven't seen. Okay? So the interval of increase in a function's domain is where the y values of the function get larger, always moving from left to right. So if you're moving from left to right, that means your x values are always increasing, even if they're in the negatives. Okay, so if I start at -10 and I move to the right, they're getting bigger, -9, -8, -7, and so on. Right? So I'm moving left to right along the graph. What's my function? What's the behavior of my function on my graph? Are the y's getting bigger or are the y's getting smaller? Okay. So for sine, we're just going to do from 0 to 2 pi because they're periodic, so they'd repeat. So starting at 0 is the function increasing or so decreasing is obviously moving from left to right. The y values get smaller, right? So right there, smaller. left to right. Just obvious, I think. Okay, so for sine, from 0, starting at 0, is it increasing or decreasing? Jason?
Increasing.
Increasing. Very good. Where does it stop increasing?
Pi over 4.
Pi over 4. Can you do it in degrees?
90.
90, which is?
Oh, wait, that's pi over 2.
Pi over 2, very good. So from 0 to pi over 2, it is increasing. So let's write that down. Now, I'm going to do this a little bit. Just watch. 0, too big. 0 to pi over 2. Now, here's the new notation. It's called interval notation, and we use brackets. But here's what's weird. I'm going to put a square bracket on this side, and I'm going to put a round bracket on that side. So this is what some people, it's just it's like a definition. I'm going to give it to you in a second. I haven't even told you why yet. Okay? But this is, some people just get them mixed up and forget which is which. So a square bracket means it includes the end value So this includes 0. At 0, that's the x, by the way. The other thing that people make a mistake is they say it's increasing from 0 to 1 because sine goes up to 1. No. We talk about the x values. Where along the x-axis is it increasing or decreasing? I don't care where it goes up to or where it goes down to. We're not talking y values here. We're talking x values. Okay, and round bracket, one way or the other, both directions obviously, whether it's a left bracket or a right bracket, is excludes the end value. Okay, try to remember that. We're only going to see it a little bit right now, but later in the course we're going to start to see it a lot. Okay, when we start talking about polynomials, you'll see it a lot more. Ooh. Any questions about that? So at 0, it's increasing. At pi by 2, it's not really increasing because it's flat. It's not really increasing or decreasing at that top point when it changes directions like a parabola does, right? Like the vertex of a parabola. Okay, it's not going up or down. So we use a round bracket for that. And then at pi by 2, it starts decreasing. Where does it stop decreasing? This is a tough question because we haven't even talked about these 5 key points yet. So I'm asking a lot of you. Yes, but that's a good answer to start. 270. What's the radian? Do you know the radians of that? Yeah, but reduced. Say that again. 4 pi over 2 be 4 over 2, which would be 2. 3 over, very good. No, that's fantastic. Good job. 3 pi by 2, that's right. Very good. So at 3 pi by 2, let me just mark these spots. So from there to there, right? From 0 to there, it's increasing, then it's decreasing. And then right here, it stops decreasing, and it starts increasing again. Because as I go left to right, the x's, it's increasing. So there's another one at that point, 3 pi over 2. It is not increasing or decreasing. It's flat at that exact point. And then all the way to 2 pi, which is 1 cycle, where it is still increasing because it would continue if you continue the graph. So then interval of decrease for sine is just going to be the opposite. It's going to be between pi over 2 and 3 pi over 2, right? It's going to be the rest of that cycle. So if you take all 3 of those intervals for sine, the 2 that are increasing and the 1 that's decreasing, you put them together, you'll get the whole period. Make sense? Okay, what about cosine? So cosine looks like this. So it starts it starts flat. It's at like a turning point. Okay, but then it's decreasing from there. So it's going to start at 0. And how long is it decreasing until?
Pi.
Until pi. and then it's increasing from pi to 2 pi. And cosine, just because of where it starts in its period, the intervals look different. But once you start translating things, it could change. Okay, so for the parent functions, like sine has 2 intervals that it's increasing, and cosine only has 1. It's just because of the nature of where they start. Yeah. Any questions about this? Everybody good? Yeah. So it's a little bit tricky at this point because we haven't looked at it a lot. Don't put too much thought into it right now. It's not going to be super important. So I'm going to draw another graph over here. That's a bit bigger to help. I think thinking about sine is the best. So sine goes like this, but if I continued it, it would go like that and like that, right? Does that make sense? So at this point on sine, where we started, it's increasing because as I go left to right, it's going up. So at the point 0, the function, the sine curve, is increasing. So I use a square bracket to show that at 0, that point, it includes the point 0, is also increasing there. Whereas when I get to here, it's not increasing or decreasing, it's flat. For just a moment, it's like when you throw a ball up in the air, it's going up. For just a moment, it stops, and then it's going down. Does that make sense? Kind of, at least. So at that point, it's not increasing and it's not decreasing. After that point, it's decreasing. Before that point, it's increasing. At that point, it's neither. So we use a round bracket to show at that point, it's not actually increasing or it's not actually decreasing. But like all the way up to just like the smallest amount before that point, all the way up to there, it is increasing. Okay, let's move on. We got a lot to do here. So there's our 2 parent functions. The A, the K, the C, and the D. It's the same for sine and cos. A tells us the amplitude. That's the amplitude. And it's also whether or not the curve is reflected. K is the change in period. So the period is equal to 360 or 2 pi. I'm going to add that in. Over K. Or if I rearrange that, K is equal to 360 or 2 pi over the period. So if I know K, I can find the period. If I know the period, I can find K. C is the phase shift. Remember, when it's in brackets, it has the opposite effect. So if it's like minus C, that's a shift to the right. If it's plus C, that's a shift to the left. And D changes the 0 line. Everybody got that? Just watch this. Take a look at, here's our lovely familiar sine curve. Here's our 5 points. Starts on the 0 line at 0. We always graph from 0 to 360 like as a base. Goes up to the max, which occurs at 90. Back to the 0 line at 180. Down to the min at 270. This is with no transformations. And then ends on the 0 line at 360. There's your 5 points. This will be useful. I'm going to talk about it now, but it'll only be useful when we start graphing. 5 points means I have a start, and then 1, 2, 3, 4 other sections to the graph. Like 4 more points after my start. My period is broken up into 4 parts. Does that make sense? After the start. You see that? That'll be important for graphing. So I'll talk about it now. Look how those points relate to radians. 90 is pi by 2. 180 is pi. 270 is 3 pi over 2. 360 is 2 pi. Because now we got to start thinking in radians. Okay, and then cosine starts at the max. 0 line, min, 0 line, max. So same 5.0, pi by 2, that's 90 on the 0 line. Pi, it's 180 at the min. 3 pi by 2, 270 back on the 0 line. 2 pi back to the max. No transformations. Let's try one. Here's what we're going to do. For each of the following, we're going to try to determine the amplitude, the vertical translation, the period, the range, the reflection, the x-axis, domain of one cycle, phase shift, and if we can, the equation. I would challenge you, encourage you to try to write out the equation as best as you can. The reason why is because once you've done, if you find the amplitude, you basically have the A value. If you find the vertical translation, the vertical shift, you basically have D. So we're going to write those out, but then off to the side, we're also going to say A equals this, D equals this. And once you've got that, you can write the equation, essentially. But if you can't by the end of the day, we'll practice that a little bit more along the road. And we're going to look a little bit at like domain and range. And I think in the homework, you're also supposed to do intervals of increase and decrease. So if maybe we'll do that if we get a chance. Any questions? First one is a sine curve. And notice that we're nice and we give it to you in degrees just to warm up a little bit. Okay. So you don't have to do these things in order, but I don't know, maybe you do. Amplitude. How do I find the amplitude? So I find the 0 line. Look at my scale. So this is -1. And from there it goes up to 0.5. And it goes down to -2.5. So that's 1.5 up and 1.5 down, which is 3 total. But then you're just going to divide that by, like the difference between the max and the min, that's going to be 3, right? But then you're just going to divide that by 2 anyway. So you're going to end up with an amplitude of 1.5. Let's do the vertical translation. So where's the 0 line for the base curve? It's 0, y equals 0. That's why we call it the 0 line. So it's -1. The phase shift, again, taking a look at my my x scale. So the first mark is 45, and it's 3 ticks up. So what am I counting by, Jason? Counting by 15, so that puts this at 30. 30 to the right. We're always going to do that. We don't talk about phase shifts as positive. In fact, I probably should have done this too. I should have said 1 down. Whoops. And I should probably spell down right. To the right, sorry. Okay, the C and the D values are negative and positive, but when we talk about vertical translation and phase shift or horizontal translation, we usually say describe the direction. What's left? The period. So the period starts. Oh, we're gonna stop. We already have the start. Where's the stop? 180 plus another 15 plus another 15, so plus 30. So that puts this at 210. So the period, the stop is 210. The start is 30. So if I subtract those, I get 180. So that's the length of my period. That's what it's asking for, the length of the period. But to find that, you're going to find that where it starts and where it stops. One cycle. Obvious for this graph. Further down, not going to be as obvious. Still okay? Okay, I think you want to just watch. You can write this down after. So now how do I translate this into my values? Well, amplitude is related to A. So I'm going to say A equals, there's no reflection, so A is just 1.5. Vertical translation is D, so D equals 1 down means -1. Phase shift 30 to the right, C equals 30. And when I go up, it's, where is that? It's minus C, so it's going to look like minus 30. That's why minus 30 goes to the right. Okay, but C is still positive. And the period is going to give me k, but k, remember, is equal to 360 divided by the period. So that's 360 over 180, which is 2. So now if I want to write my y equals a is 2, sine, k is 2. I'm going to use big brackets. You don't always need these, but for now we'll start with them. So k is 2, x minus 30 minus 1. Oh my gosh, where did 2 come from? Thank you. Is that okay? Okay, domain and range. Domain of one cycle. Who remembers proper notation for domain? Okay, and what does that stand for? Yeah, x is an element of the real numbers. X can be anything. Okay, that's our proper notation. But if it's one cycle, it's periodic. So the full sine curve, that's true. X is an element of the real numbers. But one cycle is actually from the start to the stop. So that, and see, again, we've done all the work already. When we analyze a graph, we've done all the work. So I do a line such that 30 is less than or equal to x is less than or equal to 210. Oh my gosh, don't get that backwards. Don't write it any other way. We're in grade 12 now. Those are grade 10 and grade 11 mistakes. Write it the correct way. Always start with the smallest. X is in between if you've got two ends. Okay? If you ever get feedback that you're doing it wrong on a learning goal, fix it. And the range is from the max to the min. Again, we've already thought about that. We've already gone through all this thinking. So we're going to say y is an element of the real numbers such that, so let's see, I think it was negative 2.5 is less than or equal to y, which is less than or equal to positive 0.5. So again, that has a span of 3. Half of that was 1.5. That was our amplitude, our a value. It's all connected. How are we feeling about that? Now let's do it with radians. So cosine the min is negative 1. The max is 3. So that's a distance of 4. So half of that is 2. So my amplitude is 2. And I'm going to use that to find my zero line. Hopefully the zero line is obvious, but for some reason once in a while, I don't know, at least for me, when I look at some graphs, it's not. It's just like sometimes the grid lines are small and they're maybe not as clear, and it's a little bit harder to pick out the zero line carefully. And I've seen students pick the wrong zero line, okay, as easy as that seems to be. So, you know, sometimes it jumps out at you and it's obvious, and then you can use the zero line to figure out that that's a distance of 2. But sometimes you might find the max and the min and find the difference between them and divide that by 2 and do it that way. Both ways work. And so then that's going to give us our a value. Does anybody want to tell me something about a? Nice. So it's going to be negative 2 because this is reflected from the parent cos function. Let's see. We're going to do vertical translation next. Vertical translation, don't look at the max and the min. They'll fool you. What do you look at for the vertical translation? Emma, what do you think? The zero line. Very good. Okay, that will help you ignore the reflection, ignore the max and min. They'll fool you. The zero line is what we look for, so it's up 1. Phase shift. None. 0. Right? Cos starts on the x-axis or on the y-axis, and this starts on the y-axis. So 0. Oh, so vertical translation D is 1, C is 0. Period. Okay, so it's pi minus 0, because that's where it stops. So that's obviously pi. So to find my k value, that's 2 pi divided by pi, which is 2. Often the k value will work out to a number. The pi's will cancel like that until we start doing applications. Then that doesn't happen, and your k value will be in terms of pi. But usually when we're just graphing, it cancels out nicely like that. Okay, go ahead and try to write the equation. I'm going to put a degree in for 30 because usually we state in the last equation, because usually we state when it's degrees. I should have put that before. And then when it's radians, we don't. So this one's cosine. Two x, like x plus or minus 0, so there's nothing, right? And then plus 1. Negative 2 cos 2x plus 1. If this is in brackets, that's fine. If it's not in brackets, that's fine. If you're adding something, a phase shift, you need brackets, 100%, like we had in the first one. Questions? Questions. All right. Geez, running out of time. Okay, we're going to do this one more. I think there's two, and I can skip one and go on to the next part of the lesson. And if we have time, we'll come back to that last one, or I'll do it and upload it, and you can watch it if you want to. But it's basically more of the same at this point. Oh, we forgot to do domain and range of that one. Oops. X is an element of the real numbers such that, so what was my start? 0. What was my stop? Pi. That's pretty easy. 0 less than or equal to x less than or equal to pi. We already thought about all this, right? Like we've done all this work when we analyze it. So -1 to 3. It's just how do you write it? Okay. Yeah, we got 2 more, but we'll start with this one. So this one we're going to talk about sine. This is where it gets tricky, because it doesn't show you where the start and the stop are. And with periodic functions, there's an infinite number of starts and stops. Okay? If it doesn't tell you which sine or cosine, then, I mean, you could look at the answer and see what the answer is written in, or you could just do whichever, right? That would be fine. Being able to do both is actually really important. I could come up with cos for this, or I could come up with sine for this. I could do both. Right? There's a lot of connections between sine and cosine. But this one, it told us to do it in terms of sine, so we'll do that. Okay? So the rule of thumb, and this is just a math class rule, you're going to find the start that's closest to the y-axis. So sine starts on the 0 line. I could find the max and the min, but this 0 line, I can tell where it is. It's there. And it's there. And it's there. That's where it crosses it, all those points. Which one of those is closest to the y-axis? That first one that I pointed out, which means what about my final curve that I'm going to come up with? It's going to have a reflection. Very good. Okay. So some people will they'll just find where it starts and goes up. But if it's closer to the y-axis, where it goes down, then that's the point you're supposed to use, right? And that's just so that we can give you questions that add in reflections. But in the end, it's not that big a deal. I'm more interested that you kind of understand that it starts anywhere and you could write these anywhere. And if you get good at this, you would be able to easily change your answer. Okay, so the amplitude, it goes from 2 to 0, max and min. So the amplitude is 1. And remember, it has a reflection. So the A value will be -1. The vertical translation, is up 1. So the D value is 1. Phase shift. So this is where it makes a difference if you're doing sine, if you're doing cosine, and if you pick the right starting point for whether or not it has a reflection. Okay, if I get rid of the reflection, my phase shift will change. If I chose cosine, my phase shift would change to one of those points. Right? There's your difference. Otherwise, a lot of these things are the same. Like the amplitude's the same no matter what. The vertical shift is the same no matter what. Okay, so, and this is where it gets harder. The last one was tricky, or was easy. This one's tricky. Here's pi. Just watch. 1, 2, 3, 4, 5, 6 to get there. So one of these is pi by 6. Are you with me so far okay? This is where you really got to be able to count in fractions, count in radians. And this practice, don't avoid this in the homework. Oh, this is really hard. I hate doing this nitty-gritty, figuring out the scale in terms of pi and radians and stuff. No, that's the good stuff of today, because you're going to have to come up with your own scale when you start graphing your own, and that can be very hard. Hard to the point where some people maybe never quite get it. Okay? But you can start trying to get it now by putting some time and effort into this part. So that's this is 1 pi by 6, 2 pi by 6, 3 pi by 6. I'm just going to scribble that on my, what is another way of writing 3 pi by 6? Pi by 2, very good. Which is what in degrees, just to kind of integrate into our thinking? Nice, see, we're doing it. See, it's not so bad. So our phase shift is pi by 2, and you want that version of it. Don't write 3 pi by 6. You want the pi by 2 version. Okay, and our period, here's where it starts to get even trickier. So we got to find our stop. So if that was our start, this is our stop. 4 pi. What would 4 pi be in terms of pi over 6? Because that's what we're counting. So 24 pi over 6, 25, 26, 27 pi by 6. Sheesh. A lot of the ones you do won't even be this hard. But this is a great demonstration of the kind of thinking that you have to go through. I can reduce that, divide both the top and the bottom by 3, and I get 9 pi by 2, which is nice. There are other ways of doing this, by the way. You don't have to do it this way with the math and the pi's and the fractions. Sometimes you can just fudge. I'll show you that in a second. So this is going to be 9, the stop, minus the start. 9 pi by 2 minus 1 pi by 2 is? Nice. 8 pi by 2, which is 4 pi. So how could I have come up with 4 pi? Well, there's 4 pi. 1, 2, 3. 0, 1, 2, 3. So I could have kind of just used some common sense too, right? But that being said, the fraction math is something that you need to be able to do at some point. So my period is 4 pi. I can find, I didn't do my C value. So my C value is pi over 2. And my K value is 2 pi divided by 4 pi. Those divide to 1, and I'm left with a half. Okay. Write the equation y equals. So A value is -1, so negative sine 1/2 bracket x. Remember when I said my C value is pi by 2, so minus pi by 2. That's how it looks when you've got a K value and I got rid of the big brackets. You could use them or not. When in doubt, put them in, to be clear, but there you go. And again, domain and range should be easy because we've already done all that work. Here it is right here, right? Here's the domain right there. Pi over 2. If you did if you did the period the other way where you just kind of figured where that it was 4 pi by looking at it moved 3 over, but it was a distance of 4 pi. To do the domain, you still got to go back and figure out those points. 9 pi, you still need that point 9 pi over 2 for the domain. And then the range was 0 to 2. Make sure that's clear. Any questions? We got one more thing to do. We only have 8 minutes. We'll do as much as we can, and we can finish it tomorrow if we need to. No? You all right? How many people aren't even thinking about this or just thinking about that quiz tomorrow? All right. Even and odd functions. There's a bigger part, there's like a bigger thing to even and odd functions than how it comes up in trig. And so we're going to try to talk about that a little bit. But then when we apply it to trig, it's sort of a more simple version. When we get into polynomial functions, it's going to be bigger in some ways. Okay? And at that point, it might make more sense. An even function, and so there's 2 aspects to this. And I talked about this on day 1 of this course. There's going to be a graphical aspect, which I think is simple, visual, you're going to like it. But then there's an algebraic aspect, which is a bit trickier. Okay, and so if we don't get to that today and we run out of time, that's okay. We'll add it on tomorrow. Okay. So symmetrical on the y-axis. That's easy. Okay, that's visual. Watch this. What graph is that we're looking at? What do you think? Parabola, quadratic, y equals x squared. There it is, right there. Y equals x squared. It's this one, r, the function r, y equals x squared. It's a parabola, okay? And I'm going to check and see if it's even. Is it even? When I reflect it around the y-axis, it maps back onto itself. So I've rotated it around the y-axis, okay? Like we talk about the axis of symmetry with a quadratic. But really what you're doing when you're talking about even and odd symmetry is you're rotating it around the y-axis. Okay? What if I did the cubic function, which looks like this, which actually you probably haven't really seen, so sorry about that. Okay, it starts like that. If I rotate it around the y-axis, it does not map back onto itself. So it's not even. Okay? X squared, parabola is even. If I do x to the 4th, we haven't talked about this, we will in this course. Turns out it's even as well. Now, if I change x squared, if I do like x squared plus 5x, it's no longer, see if I rotate it, it doesn't map back onto itself. So that's just the parent function of a parabola. Once you add transformations, plus 5x, something like that, it may or may not be. Some of them are, some of them aren't. Okay, if I did minus 4, that one is. That's an even function. Even function is symmetrical on the y-axis. Odd function, this is a little bit different, has rotational symmetry about the origin. So if I'm going to check odd, R, go back to the parabola because we're familiar with that. I rotate it about the origin. It doesn't map back onto itself. It's not odd. Okay. What about, what's that, S? X cubed. Whoops. Remember when I did even, it was not symmetrical. When I do odd, it is. So it has symmetry rotating about the origin. What about t, x to the 4? So remember, it's even. It's not odd. Okay, and then what about sine? Is it even? Nope. See, it's not mapping onto itself. But sine is odd. What about cosine? Not odd, but it is even. Okay, so you know what? I don't think I have enough time to do any of them. Here's what you can do. You could look at those graphs and decide whether they're even or odd or neither just by looking at them. We already talked about sine. Notice how these two have transformations. They're not the base functions that we were just looking at. So I'm going to hand out your work. Question number 2, you can't do because we haven't done the algebraic part of it. We'll add it on to the lesson tomorrow after the quiz. Any questions?